Good day, everyone. I'm Arvin Enriquez, your subject teacher for probability and statistics. So before moving forward with the topics scheduled for this week, let us define first what is a probability and statistic. Here is the formal definition of your probability and statistics. When we say probability is mathematical tool used to study randomness. It deals with the chance of an event occurring. So I want you to take note of these words. Study randomness, meaning to say, dealing with your probability, you are dealing with an event that will happen by chance or it will happen by chance. That's why it deals with the chance of an event occurring. That's why if we define your probability by simply using a formula, your probability is equal to your desired outcomes over your total possible outcomes. Again, by using your formula, we define your probability by simply equal to your desired outcomes over your total possible outcomes. Now, let's go now with your statistics. Statistics deals with the collection, analysis, interpretation, and presentation of data. You are dealing with the collection, meaning to say the data that you gathered from the questionnaire, from the survey that you constructed for your respondent. Right after collecting those data, you need to analyze by simply using your test statistics. So what will be the behavior of your data that you gathered from your questionnaire and survey? Next thing, you need to interpret. So by simply using the values that you can get from your computations, so you need to interpret and you need to decide whether your hypotheses are acceptable or not. Right after dealing with your interpretation, you're going to present your data. So in presentation of data, now you're going to present your conclusion and possible recommendation for future researcher. The combination of probability and statistics is important to all stand because the concept of probability and statistics will help you to be equipped before dealing with your practical research. Our topic for this week is all about exploring random variables. So our lesson objectives for this week, at the end of this lesson, you are expected to illustrate a random variable, classify random variables as discrete or continuous, and find the possible values of a random variable. So before we formally move forward with the topic scheduled for this week, let's deal with this pre-assessment activity. So dealing with this pre-assessment activity, we're asked to recall that the set of all possible outcomes of an experiment is called the sample space. So dealing with this entry card, you're asked to list the sample space of the following experiment. in your experiment number 1, tossing 3 coins. So in every coin, there are 2 pieces, your head and tail. So what are the possible outcomes that you can get in tossing these 3 coins? So I want you to list 3 columns. First, you need to put in your first column your head and tail. Then draw an arrow going to your next column. Then put head and tail under your tail. Then put head and tail under your head. Going to your next column, which is your third column, from your second column, head, tail, draw an arrow going to your third column, then put head, tail under your head, then put head, tail under your tail. The same thing with your head and tail from your first column under your head. So you can get a possible outcome from this idea. So your first possible outcomes is tail, tail, tail. Your second is tail, tail, head. Next is tail, head, tail. Your fourth is head, tail, tail. Your fifth is your head, head, tail. Then head, tail, head. Then tail, head, head. And last, your head, head, head. So there are 8 possible outcomes dealing with your experiment number 1. Now, moving forward with your experiment number 2, rolling a die and tossing a coin simultaneously. So in a single die, there are 6 pieces. Your first piece represents 1, your second represents 2, up to the last piece which represents your number 6. In a single coin, there are 2 pieces, your head and tail. Now, what are the possible outcomes that you can get in your experiment number 2 when you roll a die and toss a coin simultaneously? Now, let's list down all the possible outcomes that we can get from your experiment number 2. You're going to partner your first piece in your coin, which is your head, to your 6 pieces under your die. So that will be head 1, head 2, head 3, head 4, head 5, and head 6. Same thing with your tail. You're going to partner this tail to 6 pieces of your die. So that will be tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Meaning to say, dealing with a die and a coin, once we roll a die and toss a coin simultaneously, there are 12 possible outcomes. So this set of all possible outcomes are called sample space. Our lesson introduction. If 3 coins are tossed, what numbers can be assigned for the frequency of heads that will occur? If 3 cards are drawn from a deck, what number can be assigned for the frequency of face cards that will occur? The answers to these questions require an understanding of random variables. Discussion points. Suppose 3 cell phones are tested at random. We want to find out the number of defective cell phones that occur. Thus, to each outcome in the sample space, we shall assign a value. So dealing with these discussion points, we're going to assign a variable that will represent the number of defective cell phones in every possible outcomes that we can get in your sample space. So please do take note. We are asked to find out the number of defective cell phones. So you're now assigning a variable that will represent the number of defective cell phone in each possible outcomes. Here is the continuation of your discussion points. Suppose 3 cell phones are tested at random. We want to find out the number of defective cell phones that occur. That's why we're going to assign a variable that will represent the number of defective cell phone in each possible outcomes. Before you will dealing with that, so we need to list down all the possible outcomes. Here, in your first possible outcome, we assume that these 3 cell phones are non-defective cell phones. So we use letter N to represent the non-defective cell phones and B to represent the defective cell phones. In your first possible outcomes, we assume that your 3 cell phones are non-defective cell phones. In your second possible outcomes, we assume that your third cell phone is a defective cell phone. Next, in your third possible outcome, we assume that your second cell phone is a defective cell phone. In your fourth possible outcome, we assume that your first cell phone is a defective cell phone. Now, dealing with your fifth possible outcome, we assume that your second and your third cell phones are defective cell phones. Same thing with your sixth possible outcome. Your first and third are defective cell phones. Then, for your seventh possible outcome, we assume that your first and second cell phones are defective cell phones. In your last possible outcome, we assume that these 3 cell phones are defective cell phones. So for the continuation again of your discussion points, to each outcome in the sample space, we shall assign a value. 0 if there is no defective cell phone, 1 if there is 1 defective cell phone, 2 if there are 2 defective cell phones, 3 if there are 3 defective cell phones. The number of defective cell phones is a random variable. As you can see in the table, we're going to list all the possible outcomes in your first column, which start with your N and N. So we assume that these 3 cell phones are non-defective cell phones, up to the last possible outcomes when we assume that these 3 cell phones are defective cell phones. In your second column, we assign variable X to represent the number of defective cell phone in each possible outcomes. In your first possible outcomes, since we assume these 3 cell phones are non-defective, meaning say your random variable X is equal to 0. because there is no defective cell phones in your first possible outcome. Same thing with your second. You're going to count the number of defective cell phones. As you can see in your second possible outcomes, there's only one defective cell phone. That's why the value of your random variable x is equal to 1. In your third possible outcome, again, we're going to count the number of defective cell phone. There's only one defective cell phone. That will be your second cell phone in your third possible outcome. That's why, again, the value of your random variable x is equal to 1. Same thing with your fourth possible outcome. There is only one defective cell phone here. That's why your random variable x is equal to 1. Next, in your fifth possible outcome, there are two defective cell phones here. That's why the value of your random variable x is equal to 2. Same thing with your sixth possible outcomes. You're going to count. So there are two defective cell phones here. That's why your random variable x is equal to 2. Next, in your seventh possible outcome, still there are two defective cell phones. That's why the value of your random variable x is still equal to 2. Now, in your last possible outcomes, we assume that these three cell phones are defective cell phones. That's why the value of your random variable x that will be mapped for your last possible outcomes will be equal to 3. So if you try to assess what are the numbers that reflect as a value of your random variable x in your second column. So that will be 0, 1, 2, and 3. So this 0, 1, 2, and 3, these are possible values of this random variable x. That's why the possible values of this random variable are 0, 1, 2, and 3. So if you're asked to find the value or the possible values of this random variable, you just simply look at in your second column. So those numbers that reflect as a value of your random variable x in your second column, these are the possible values of this random variable. Here is the formal definition of your random variable. So when we say random variable, this is a function that associates a real number to each element in the sample space. But we need to clarify things. So when we say real numbers, these are negative numbers, 0, and positive numbers. But dealing with your random variable, this real number pertains to 0 and positive numbers only. So you cannot put a negative value or negative numbers for your random variable or as a value of your random variable. It is a variable whose values are determined by chance. So you need to take note of that. This variable or the value of this variable or values of this variable are determined by chance. So for us to understand more what is a random variable, your sample space, your possible outcomes, let's deal with this example number 1. A while ago, we're done with your pre-assessment activity. Under that activity, there's an experiment number 1 there, tossing 3 coins, and release all the possible outcomes for that experiment. the same scenario with this example. So we're going to list down all the possible outcomes that we can get in tossing 3 coins. So a while ago, there are there are 8 possible outcomes, with this experiment. So for this problem, so suppose 3 coins are tossed. Let y be the random variable representing the number of tails that occur. So meaning to say, we're going to use variable y to represent the number of tails in each possible outcome. So find the values of the random variable y. So we're going to count the number of tails in each possible outcomes. So whatever the number or numbers that reflect as a value of your variable y, that will be the possible values of your random variable. Now, with this table, you're asked to complete the table below. So the solution for your example number 1, your first step, you need to deal with your sample space. So we define your sample space as a set of all possible outcomes. So you need to list down these possible outcomes in this format. So for your step number 1, so determine the sample space. Let H represent head and T represent tail. Therefore, the sample space for this experiment is your S, that will represent your sample space, will be equal to your tail, tail, tail as your first possible outcomes, tail, tail, head, tail, head, tail, head, tail, tail, head, head, tail, head, tail, head, tail, head, head, up to the last possible outcomes, which is your head, head, head. So in total, there are 8 possible outcomes in this experiment. For your step number 2, we're now dealing with your table. So your step number 2, we're asked to count the number of tails in each outcome in the sample space and assign this number to this outcome. So with the sample or with the possible outcomes that you list in your step number 1, you're going to list down these possible outcomes in this format using your first column. So in your first column, you're going to list all the possible outcomes from tail, tail, tail up to head, head, head. Now, the problem mentioned that we're going to use the variable y to represent the number of tails in each possible outcomes. So for your first possible outcomes, which is tail, 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 so we're going to count the number of tails here. So since your first outcome or your first possible outcome is tail, 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 then the value of the random variable y will be equal to 3. Same thing with your second possible outcome. So tail, tail, head. So there are 2 tails here. Therefore, the value of your random variable is equal to 2. Same thing with your third possible outcomes. There are 2 tails here. Therefore, your value or the value of the random variable y is equal to 2. Same thing with your fourth possible outcomes. There are 2 tails here. Therefore, the value of the random variable y is still 2. Under your fifth possible outcome, there's only one tail here. Therefore, the value of the random variable y is equal to 1. Same thing with your 6 and 7 possible outcomes. So there is only one tail for your 6 and 7 possible outcomes. Therefore, the value, no, the value of this, the value of these two possible outcomes, or I mean the value of the random variable that will be mapped in these 6 and 7 possible outcomes that we have in your first column are equal to 1. For your last possible outcomes, which is your head, 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 since we assign your variable y to represent the number of tails in each possible outcome that we have or that we had in your first column, since your last possible outcomes is head, 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 there is no tail here, meaning to say the number or the value of your random variable y is equal to 0. Now, if you try to assess, or if you try to observe your second column, so there are 4 numbers that reflect as a value of your variable y here. These are 0, 1, 2, and 3. So meaning to say, the possible values of random variable y is 0, 1, 2, and 3. So with this slide, we're dealing with your random variable or the formal definition of your random variable. So any letter can be a random variable. So it depends on you what letter are you going to use. So here, a random variable x represents a numerical value associated with each outcome of a probability distribution. That's why we assign a random variable to represent a certain thing in your possible outcomes that we have in your experiment. For example, a while ago we're done with your tossing 3 coins. So we assign a variable y to represent the number of tail or tails in each possible outcomes. That's why there is a numerical value associated with each outcome of a probability distribution. So this value represent, or this value are values that will represent your random variable. So there are two types of your random variable. First is your discrete, and your second is your continuous. So a random variable is discrete if it has a finite or countable number of possible outcomes that can be listed. So please do take note of this. Dealing with your discrete random variable, it has a finite or countable numbers or number of possible outcome. Meaning to say, the value that you can get from this random variable is more specific and exact. And it is finite and countable. Dealing with your continuous, it has an uncountable number or possible outcomes. Meaning to say, the value of your continuous random variable can change from time to time. So there is no specific or exact value of this random variable. Unlike with your discrete random variable, it is countable and finite. it is more, or there is a specific or exact value of this random variable. Again, dealing with your discrete, there is a specific and exact value, and it has a finite or countable number of possible outcomes. Dealing with your continuous, it can change from time to time. Uncountable number or possible outcomes. Meaning, say there is a wide range of values that you can map to this kind of random variable. So there is no specific or exact value. It can change from time to time. So for us to understand more what is a discrete and continuous random variable, so let's deal with these examples. One example for your discrete and one example for your continuous random variable. The distance your car travels on a tank of gas. Is it discrete or continuous? So, based on the explanation, so the distance your car travels is a continuous random variable because it is a measurement that cannot be counted. All measurements are continuous random variable. Sir, bakit ganon? Kasi, for example, no, some student will ask, Sir, bakit continuous? Eh, meron naman exact value, meron naman specific value ng volume ng gas na kinarga ng may-ari, the owner of the car. Now, sabi ng statement, the distance your car travels on a tank of gas. For example, when the owner of car, no, went to a gas station, then nagpakarga lang siya ng 1 liter. It doesn't mean yung 1 liter na yon or the distance that he can travel or she can travel with that 1 liter is 1 kilometer. So it depends kung paano niya patatakbuhin yung sasakyan. So, for example, sininda niya yung makina, naubos niya yung 1 liter, pero hindi niya pinatakbo yung sasakyan. So, meaning to say, hindi natin pwedeng sabihin that using a 1 liter gas is yung ite-travel or the distance na pwedeng i-travel ng sasakyan is 10 kilometers, 1 meter. No, it depends on the speed, it depends on how the driver handle his car. That's why there is no specific or exact value. So there is a wide range of values that can be mapped to your distance using that 1 liter gas. So therefore, your number 1 is a continuous random variable. Next, example, the number of students in a statistics class. The explanation, so the number of students is a discrete random variable because it can be counted. So in every class, no, there is an advisor. Those advisors have their list of students. So meaning to say, you can count the number of students under that section, under that particular class, no? And there is a specific and exact values that can be mapped to the number of students. For example, in our school, most in the public schools, for example, there are 45 students per class. In some schools, that will be the standard or the standard that we need to follow as. So if we follow a standard, for example, no, so there are 45 students per class. So meaning to say, alam mo kagad that uh, there are 45 students under that class. So in every class, there is an exact and a specific number of students. Hindi siya pwedeng magbago from time to time. Na after 1 minute, 46 na yung students mo. After 30 seconds, 47 na. So meaning to say, doon sa time interval ng pagbabago, is hindi ganon kabilis. So meaning to say, if someone will ask you, no, how many students are there in your class? So you can say 45, 46, 47 right away. So there is a specific and exact values that cannot change from time to time. So that will be your discrete random variable. So let's deal with this activity. So we're asked to classify the following as discrete or continuous. Number 1 statement. The number of senators present in the meeting. Di po ba, no? In every meeting, there is an attendance. From that attendance, you can count how many senators are present in that particular meeting. So meaning to say, if someone will ask you how many senators are present in that particular meeting, you can actually give an exact and specific value. For example, in this meeting, there are 18 senators. So when you say there is an exact and specific value, therefore, your number 1 is a discrete random variable. For number 2 statement, the weight of newborn babies for the month of June. So the weight of newborn babies can change from time to time. So hindi naman po tayo pwedeng mag-conclude na yung weight ng pinanganak ng June 1 is the same weight nung yung pinanganak ng June 2. So yung weight ba ng baby na pinanganak ng June 1 is the same weight nung ipapanganak yung baby na pinanganak ng June 2? Definitely not. So meaning to say there is a wide range of values that we can map, no, with this weight of newborn babies. So there is no specific, there is no exact values. So it can change from time to time. So meaning you say your number 2 statement is a continuous random variable. Number 3, the number of ball pens in the box. So pag bibili po ba tayo ng ball pen na nakabox, meron bang label yon? Meron bang number of ball pens inside that box? So definitely yes, no? So when we buy a box of ball pen or ball pens, no? So merong label dun sa box. For example, 24 pieces. 10 pieces per box. So if someone will ask you, how many ball pens are there? Or how many ball pens are there inside that box? So you can answer that directly because there is a specific and exact value that can be mapped, no, to the number of ball pens in that particular box. So right away, pwede mo sabing 24 pieces, 10 pieces, 15 pieces because meron ng label dun sa box for the number of ball pens. Therefore, number 3 is a discrete random variable. Number 4, the capacity of an auditorium. Diba? In every structure, in every auditorium, or in every structure, there is a designed strength for the structure to resist the loads na ibinibigay po ng mga live load, ng mga dead load. These are people who will enter and furnitures that we can put inside that structure. Now, if the statement, for number 4, the statements that the capacity of an auditorium. Kaya nga po, para maiwasan ng stampede, para maiwasan yung pag-collapse ng building, so nagkakaroon po tayo ng maximum capacity in every building. So for example, in this auditorium, ang maximum capacity lang niya is 5,000 people. So 5,000 people lang yung pwedeng mag-enter doon sa ating auditorium. So hindi na pwedeng mag-exceed, pwedeng less than 5,000 or eksaktong 5,000 but not more than 5,000 people. So, meaning to say, your statement number 4 is a discrete random variable because in designing a structure, there is a specific strength that we assign in every structure or in every members of the structure na pwede na strength that can resist or that can handle an specific and exact number of individuals na papasok doon or mag-enter doon sa ating structures or auditorium na tinatawag natin in your statement number 4. Number 4 is a discrete random variable. Number 5, the number of households with television. So, with the survey, magkakonduct ka ng survey, magbabahay-bahay ka, for example, you will ask each family or each household kung meron ba silang television. So, meaning to say, if you conduct a survey within this vicinity, for example, in Poblacion 3, Herona Tarlac, magkakonduct ka ng survey. So, tatanungin mo, in each family or in each household, meron ba silang television? So, within that particular and within that vicinity na sinubject natin for that survey, is magkakaroon tayo ng exact and specific value because alam mo kagad that there are 300 household with television based on your survey. Alam mo kagad, hindi nag-change yun from time to time. So once you conduct a survey, your survey can provide you an specific and exact values of the number of household with television. Meaning say number 5 is a discrete random variable. For number 6 statement, the height of mango trees in the farm. Si tree number 1 ba is the same yung height with the tree number 2? Maybe almost the same, but they're not totally the same. So meaning say you cannot come up with the idea that the height of this tree number 1 is the same with the height of tree number 2 and the height of tree number 3. So meaning say there is no specific value for that will be mapped, no, for the height of mango trees in a farm. So it can change from time to time. It depends kung paano lalaki, kung paano tutubo yung mango trees natin. So there is no specific and exact value. So hindi mo siya pwedeng sabihin na sa 3 meters ang height ng lahat ng mango trees in this farm. So hindi ka pwedeng mag-come up with that idea. So still there is a difference, no? Kahit na pa 2 inches lang yan, still there's a difference. So there is a wide range of values that can be mapped to the height of mango trees in a farm. So therefore, number 6 is a continuous random variable. Number 7, the area of lots in subdivisions. So pag bibili po tayo ng lupa, no, if we decided to buy a lot, no, in a subdivision, there is an specific and exact value of area in every lot. For example, sa lot 1, 35 square meters lang. In lot number 2, no, may 45 square meters. So pag bibili tayo ng lupa in a subdivision, there is an exact and specific value and it's countable. So alam mo kaagad na pag bibili ka ng lupa, no, in a subdivision, within this area, lahat ng lot dito is tig to 35 square meters lang. For that portion, meron lang tayo doon na area na tig 45 square meters. So meaning to say, hindi siya nagbabago from time to time. So there is a specific and exact value. So hindi wide yung range ng values that can be mapped in the area of lots in a subdivision. Because there is a set, no? Nakaset na po yung area. Pag bibili ka ng lupa in a subdivision, hindi po yan nagbabago from time to time. Hindi naman 35 square meters ngayon yung sinet ng owner ng subdivision. Tomorrow is magiging, or mamayang after 1 minute, magiging 35.5 na yan. Magiging 36 na yan. So there is no such thing like that. So pag the area of a lots in a subdivision, there is a fixed, exact, and specific value that can be mapped to that area. Kung 35 square meters lang yan, 35 square meters lang yan. Kung 45 square meters lang yan, 45 square meters lang yan. So, hindi yan nagbabago from time to time. Therefore, number 7 is a discrete random variable. For statement number 8, the number of students who join a field trip. So, dealing with a field trip, no? So, alam na kagad ng advisor, no, ng admin ng school, kung ilang estudyante ang sasali. Because nagkaroon na ng ng survey, nagtanong-tanong na yan sa mga bata kung sino ang mga gusto sumama. So, sino yung mga interested sumama doon sa field trip na yon, with that particular field trip. So, if someone will ask, the admin or the advisor of that particular class, how many students who decided to join the field trip? So, alam kagad ng admin ng school or advisor ng klaseng pagtatanungan na yon na merong 300 students ang sasali because merong list of students who will join that field trip. So, alam kagad yung there's a specific and exact value that can be mapped to the number of students, no, who join a field trip. That's why your statement number 8, is a discrete random variable. Number 9, the number of winners in Lotto for each month. Is it discrete or continuous? Ang PCSO ba nagkakaroon ng data? How many winners, no, ang meron tayo sa isang buwan with that particular month? Definitely, yes. So, nagkakaroon po ng data ang PCSO, no, na ilan ba yung tumama ng loto within this month. So, alam kagad with the system of PCSO, alam nila kagad na merong ganitong tumama, ilan ang tumama for January, for February, for March. So, there is a specific and exact value. So, hindi pwedeng magbago yan from time to time. For each month na pinag-usapan the number of winners in Lotto for each month. So, meaning saying number 9 is a discrete random variable. Number 10, the weight of professional boxers. The question here is that, what division? So, meron din kasi tayong heavyweight, welterweight division, mga ganun. So, the weight of professional boxers in what division? No? So, hindi natin alam, in the statement, hindi sinabi kung anong division. So, your number 10, the weight of professional boxers, so there is no specific value for that. Kasi hindi mo alam, it can be 80.5 kilograms. Pwedeng maging 90.5 kilograms. So, there is a wide range of values that can be mapped to the weight of professional boxers, because in every boxers, there is no specific, there is no exact value that can be mapped to their weight. Bakit? Kasi pwedeng magbago yan from time to time, no? Even in a single minute or in a single hour, magbabago yung weight ng So there is a difference. For example, pinawisan. For example, naglakad-lakad siya na gano'n. So, kahit na pa napaka-minimal, kahit na pa napaka-minimal lang yung difference na na-measure natin before siya lumakad, right after niya lumakad, do sa weight na nakuha natin before and after, kahit na pa ganun lang ka-minimal yung difference, still a difference. So, meaning say there is no specific and exact value for that can be mapped, to the weight of professional boxers. Therefore, number 10 is a continuous random variable. So for your activity number 1, so same scenario with your example number 1 and discussion point. You're going to deal with a random variable, so you need to list down all the possible outcomes with the involvement of your point coins in this experiment. So you're going to use a variable C as your random variable that will represent the number of heads in each possible outcome. So you're going to count the number of heads in each possible outcome. Then whatever values that reflect as a value of your random variable C here, these are possible values of your random variable. So you're going to assess and check here. So whatever the number that reflect here as a value, if that is 0, 1, 2, 3, 4, then you need to put 0, 1, 2, 3, 4 as a value or possible values of your random variable C that represent the number of heads in each possible outcomes na meron tayo with this activity. In your activity number 2, you're going to classify, or you're asked to classify the following random variables as discrete or continuous. So you need to classify lang with your statement under your A up to letter E. There are 5 statements here. Then you're going to classify if the given statement is a random variable as discrete or continuous. So you need to write lang naman without explanation. You need to classify the given statements if this statement pertains to your discrete or continuous random variable. So this will be the end of our session. So if you want to comment, share, and subscribe, do so. So please comment your name, your section, and if you have your suggestion, comment, or questions about our session, so please comment down below. So if none, then leave it. So thank you for listening. God bless to everyone.